Hi guys, today we are going to discuss about the next point of current electricity, and it is a Wheatstone's bridge. The principle on which the Wheatstone's bridge works. Let us see that principle. No current flows in between two equipotential points of electric circuit. No current flows in between two equipotential points. समजा दोन पॉइंट्स इलेक्ट्रिक सर्किटमधील दोन पॉइंट्स, त्या पॉईंट्सवरती जर सेम सेम पोटेन्शियल असेल, इक्वल पोटेन्शियल असेल, तर त्या दोन पॉईंटमध्ये इकडून तिकडे किंवा तिकडून इकडे करंट फ्लो होत नाही. हेच मुख्य तत्व आहे वेटस्टोन्स ब्रिज, की ज्यावरती तो वेटस्टोन्स ब्रिज वर्क करतो. नो करंट फ्लोज इन बिटवीन एनी टू इक्विपोटेन्शियल पॉइंट्स of an electric circuit. Now let us see the Wheatstone's bridge. This is the Wheatstone's bridge. Now construction. This Wheatstone's bridge, it consists of 4 resistors P, Q, R, S. It consists of 4 resistors PQRS. They are connected in such a way that so as to bridge A, B, C, D will form. 4 resistors PQRS are connected in such a way that so as to bridge A, B, C, D will form. Galvanometer is connected in between point B and D. Galvanometer is connected in between point B and D. A battery of EMF E plus K are connected across point A and C as shown in this diagram. A battery of EMF E plus K are connected in series across the point A and C as shown in circuit diagram. Let I be the total current flows through the circuit. Here point A, point B, point C, point D, these are the junction points. I be the total current. Now I1 be the current flows through P, I2 be the current flows through S, and Ig be the current flows through galvanometer. This is the construction of Wheatstone's bridge. Let us see that construction. This is the part of construction. Now we are going to discuss about the working. Let I be the total current and I is equal to I1 plus I2. From circuit, total current I is equals to I1 plus I2. In working, see this is the Wheatstone's bridge. Now let us concentrate on the working. Let I be the total current. I be the total current. Here A point is a junction point. Incoming current, total current. I1 and I2 are the outgoing currents. From this junction point, I am able to write that incoming current is equal to outgoing current. I is equals to I1 plus I2. This is the equation number 1. Now by applying KVL loop on A, B, D, A, ABDA, क्रिचॉप्स व्होल्टेज लॉ आपण ह्या लूपवरती अप्लाय करणार आहोत. हा क्लोज लूप आहे कारण याचा स्टार्टिंग पॉईंट आणि एंड पॉईंट सेम आहे. नाउ लेट अस स्टार्ट to trace that closed path. Let us consider the first segment AB. In this segment we come across the resistor P and I1B, the current flows through it. While tracing the loop we follows that current, therefore the potential drop across P becomes negative, therefore it is minus I1P. Now the next segment of that closed path, it is BD. IGB, the current flows through the galvanometer. While tracing this closed path we follows this current, therefore the potential drop across the galvanometer, it becomes negative and it is minus Ig into G. Last one segment of this closed path, it is a DA. While tracing this segment, while tracing this path we come across the resistor as I2B, the current flows through it. While tracing this path we oppose that current, therefore PD across this S becomes positive, therefore that PD is plus I2S. Here the path is completed, therefore it is equal to 0. This is the equation number 2. Now let us see the another closed one path BCDB. While tracing this closed path, let us concentrate on the first segment, it is a BC. While tracing this segment from B to C we come across the resistor Q. Here I1 minus Ig is the current flows through it. While tracing this path we follows that current, therefore the potential difference across this Q is taken as a negative. See here, and it is minus into bracket I1 minus Ig into Q. This is the total current flows through Q and this is the resistance of Q. Then after the next one segment, it is a CD. While tracing this path, here we oppose that current which flows through the resistor R, and while tracing this path we oppose that current, therefore the potential difference across this path is taken as positive and it becomes plus into bracket total current into resistance. It is total current I2 plus Ig into R. Then after the last one segment of this closed path, it is DB. While tracing this path we oppose that current which flows through galvanometer, therefore the potential difference across the galvanometer is taken as positive and it is plus Ig into G. This is the current flows through galvanometer into total resistance of the galvanometer. Here path is completed, therefore it is equal to 0, and this is the equation number 3. You observe the equation 2 as well as equation 3 very carefully. ज्यांना क्रिचॉप्स व्होल्टेज लॉ हा व्यवस्थित समजलेला आहे त्यांना तो KVL आता या क्लोज्ड पाथवरती अप्लाय करत असताना डाऊट्स किंवा डिफिकल्टीज येणार नाहीत. मात्र त्यासाठी प्रिव्हियस लेक्चरमधील क्रिचॉप्स व्होल्टेज लॉ आणि त्याचे साइन कन्व्हेन्शन्स हे तुम्ही काळजीपूर्वक अभ्यासलेच पाहिजेत. नाउ लेट अस कंटिन्यू द रिमेनिंग पार्ट ऑफ वर्किंग. when the bridge is balanced means point B and point D becomes equipotential and no current flows through the galvanometer, and we know the principle of the Wheatstone's bridge: no current flows in between equipotential points. When point B and point D becomes equipotential, therefore no current flows in between point B and D, therefore the current flows through the galvanometer, it becomes 0. See the sentence: when the bridge is balanced, then Ig is equal to 0, galvanometer current is 0. Therefore the equation 2 becomes, Ig ची value इथे 0 put up करायची आहे. Therefore equation 2 becomes minus I1P. This term totally becomes 0, remaining term plus I2S. It is equal to 0. By rearranging, by transferring this term to RHS, we got I2S is equal to I1P. And then after, or that is I1P is equal to I2S. This is the equation number 4. In similar manner, the equation 3 becomes, see the equation 3. By putting the value of Ig is equal to 0, Ig is equal to 0, Ig is equal to 0, we got it is equal to minus as it is I1 cube plus sign as it is I2 into R, and last one term totally becomes 0. It is equal to 0. By solving this step, we got I2R is equal to I1 cube. By transferring this term to RHS, we got I2R is equal to I1 cube. By rearranging this step, we got I1 cube is equal to I2R. This is the equation number 5. By taking the ratio of equation 4 and 5, we got, by dividing equation 4 by equation 5, we got I1P divided by I1 cube is equal to I2S divided by I2R. I1, I1, I2, I2 get cancelled. Therefore, it becomes P upon Q is equal to S upon R. P upon Q is equal to S upon R, and this is the balancing condition of Wheatstone's bridge. P upon Q is equal to S upon R. P upon Q is equal to S upon R. See the bridge. P upon Q is equal to S upon R. P divided by Q is equal to S divided by R. This is the balancing condition of Wheatstone's bridge. Now let us see one of the problem which is based on the Wheatstone's bridge. See the problem. 4 resistors 10 ohm, 10 ohm, 10 ohm and 15 ohm form a Wheatstone's bridge. What shunt is required across 15 ohm resistor to balance the bridge? This is the problem. Now let us see the given data. And this is the rough diagram or a circuit diagram of Wheatstone's bridge. It consists of 4 resistors R1, R2, R3, R4. They are connected in such a way that so as to bridge is formed. R1 10 ohm, R2 10 ohm, R3 10 ohm and R4 15 ohm. Here S be the shunt resistance connected across R4 for to balance the bridge, connected across this 15 ohm resistor for to balance the bridge. From this circuit, the equivalent resistance of parallel combination, it is equal to Rp. Rp is equal to the equivalent resistance of this parallel combination. On numerator there is a product, it is R4 into S divided by R4 plus S. Therefore, by putting the value of R4 is 15S, the equivalent resistance of parallel combination. Equivalent resistance of parallel combination calculate करत असताना जे दोन रेजिस्टर्स पॅरल कॉम्बिनेशनमध्ये कनेक्ट केले असतात त्यांचा न्यूमरेटरला प्रॉडक्ट घ्यायचा आणि डिनॉमिनेटरला ॲडिशन घ्यायची, कारण 1 upon RP here 1 upon RP is equal to 1 upon S plus 1 upon R4. By solving that step, we got Rp is equal to R4 into S divided by R4 plus S. It is equal to 15S divided by 15 plus S. This is the equivalent value of parallel combination Rp. when the bridge is balanced, R1 upon R2 is equal to R3 upon Rp, equivalent resistance of parallel combination. See this step, it is equal to R1 upon R2 is equal to R3 upon Rp, R1 10, R2 10, R3 10 and Rp 15s divided by 15 plus s. By solving this step, 10 get cancelled, and by transferring this term to LHS we got 15 s divided by 15 plus s is equal to 10 upon 1. Then after by taking the cross product we got 15s is equal to 10 into bracket 15 plus s. Therefore it becomes 15s is equal to 10 into bracket 15 plus s. By dividing 5 on the both sides we got 3s is equal to twice into bracket 15 plus s. 3s as it is, taking the product 2 into 15, 15 2s are 30 and plus sign as it is twice s. By transferring this twice s to LHS it becomes minus 3s minus twice s is equal to 30, that is s is equal to 30 ohm. This is the value of shunt resistance which is connected across R4. Then after that bridge is balanced. By connecting this resistor across R4, that bridge will be balanced. Okay, thank you.